Okay, so day 45 ahead of linked list, reverse the nodes of list k at a time and return the modified list. K is a positive integer and is less than or equal to the length of linked list. If the number of nodes is not a multiple of k, then left out nodes in the end should remain as it is. You may not alter the values in the list nodes. Only nodes themselves may be changed. All right, so we have a linked list like 1, 2, 3, 4, 5, and also k. So it means that reverse the nodes of the list k at a time. So we need to reverse each 2 nodes or what? For example, here we have 3, so we just 2. Okay, so we first reverse 2, then 2, and then 2. Okay, so it's interesting. So let's imagine that we have some linked list and we have some k value. K value would be less or equal to 1 and less than a list length. So from our constraint, we have 1 and 5,000 and also some values. So if, for example, let's take this as an example. Let's say that k is equal to 1. So if k is equal to 1, then we just return the current list, and that's it. If k is equal to 2, this means that we should reverse all 2 values. So it means that first we need to take k times of our linked list and then reverse this k times, right? Then we have like the next node, it would be 4, and we take the next k nodes in our linked list. So I think that first let's talk about approaches. So the first approach is we collect some nodes, I don't know, in this stack, for example. So we put 1, 2, 3, and then we take from the stack and we create this list and we put the next node as the next value. So I think it would be the best decision. So let's do this. So we have a head node, right? Let's create our result as equal to head. So result equal to head, and we should return this result. Then we also have our current node. It will be also equal to head, and while current is not equal to null, we should do some operation. So first we should take while int I equal to k, and while I is greater than 0 or current is not equal to 1, and current not equal to 1, what we will do, we create a stack here. So we create a stack with list nodes, stack, new stack, and we have our current node, right? And we then operate, and we just put all values into the stack push current, and then current equals to current next. After this, we should update our I. So we decrement I by 1, and then we should recreate this node. So we just recreate all this node. So we create like list node. It would be not current, but like head equal to new list node with stack we actually, I think we can, here we just can put integer values. So like current push value. So we just put values here, right? And here we take stack pop. We pop from our stack. And yeah, we pop from our stack. Yeah, we pop from our stack, and then while stack is empty, is not empty, we create a new list node. So it will be new list node. Also, we pop this element from the stack, so it would be new node. And then we do like head next equal to new node, and head is equal to new node. Right? So here we actually pop out our stack values. And then again, we have like our current node and so on. Yeah, so the problem here that what we should do we should here like it would be null, and here we create a head node, and we should tell like this: if result equal to null, then result equal to head, and we pop this head and recreate this node. So here we have like this part, for example, 1 and 2. Here we create our result, but then we have our current. So we need to create here like, I think, a dummy node. So yeah, let's create a dummy node here. New list node with -1 and head. So here is dummy node, and dummy node have this next value. Dummy node has this value. And then we have current not null, current value 2. Yeah, it's hard here. It's hard to do this way. Yeah, because here we can like reflect, then we have one, and then we should like reflect this one. Yeah, I think this is quite hard. Let's think about maybe approach. So I think that recursive approach would work better here. So let's imagine that we have a linked list and we have some recursion function where we put we should return from this recursion function next. So when we call like recursion, we should return next a list node, and also we have head. So from here we return, but here we need to actually revert it. So it's like index. Let's think. Okay, so let's think. So here we have, for example, we are calling with k, so k -1. So here, for example, we need to revert like 3 elements. So we call this with 3, like, I don't know, with this one with 3, with 2, with 1. And when we call this with 1, then actually we need to revert to this function. We revert this function, then we take the next one, and then we revert next one. How we can do this? We can have like a list node, then we can have a recursion function. Here it would be head. Here, head we have current, and also we have k, right? We have recursion current, heads, and k, and we can check if k is equal to 1. Then we need to take the list node next, car next, and we need to revert head k times, like, k. Okay, it's hard to do this. Head to current, maybe, right? Yeah, maybe head to current, so we revert this function, and we have like new head. And here, like if current equal to null, we just return null. Here we revert. And you had null. Here we update. Next, we also need to take this next. Here we revert. And here the current. And you add next equal to recursion. Here we need to update head to next. Here we call the recursion with head with new head and k minus 1. And here also k equal to we need to have some, I don't know, global k int j, let's say, so equal to j, and return new head. And then we need to implement this revert function. Where we have list head and current, like head and tail. So here we need like list node previous equal to null. Then while head is not equal to null, let's say not equal to tail, we are reverting, so we take the next element, next head next, then head next equal to previous, then head equal head equal to next, and previous equal to head equal to next, and here we return previous. And here we return recursion of head, key, and key. Okay, list node. Rec head here into BJ. Okay, node pointer. Next. Head. Cannot assign field next because local. Head next. Okay, let's think. So if current equal to null, we return null, then we have current next. If k is equal to 1, then we have our head and current node, right? Have head, current node. So we definitely need to get next. We have head and current node. So we revert this function, and then we had equal to next. Yes, k is equal to j, and head. Yet new head else new head revert. And then you had next should be equal to recursion call and return and head from here. Okay, and recursion, so head next. Next, and here also head k minus 1 j. Okay. Yes, k. Else, so 3, then return recursion head and current. Or head next. Current next, I think. Let's run. Next, revert, previous, head and tail. Previous equal to null. When head is equal to tail, key equal to 1. What if k equal 1? We just return head. And here we have k equal to 2. Yes, k equal to 2. So how it works? So we have our key. So first we go here. So head 1, then 2, and we have head and 2. Then head is not equal to tail. We take next. Head previously equal to head. I think what we can do like this. So current next equal null, and then current x equal null, and then we don't need current, we just need head not equal null. Okay, so we have 2, 3, 4, 5, 4, 3, 4. Yeah, something complex. Okay, so I think that, yeah, it's not solution for today. So see you tomorrow.